Every time Tesla drops a sensor from its self-driving hardware stack, a new wave of hand-wringing headlines follows. The most common accusation? That Elon Musk is cheaping out, that getting rid of radar and more recently avoiding LiDAR altogether is a dangerous decision that puts lives at risk. The thinking goes, more sensors must mean more safety. Radar, LiDAR, ultrasonic, why not all of them? But that line of thinking reveals a fundamental misunderstanding of what makes self-driving technology not just functional, but scalable, reliable, and elegant. Let's be clear, redundancy is good. Redundancy is what keeps planes in the sky when a system fails. It's why we have multiple engines, backup generators, and redundant data centers. But redundancy is only valuable when it provides reliable backup, not overlapping confusion. And that's the problem with stuffing every sensor into a car. You end up with multiple truths that don't always agree, and a system that now has to arbitrate between those truths. I've been down this road before. Back in the 1980s, I built hobby robots, and I loaded them up with ultrasonic range finders, humidity sensors, temperature probes, anything that Radio Shack had new on the shelf. It was fun, for sure, but at the end of the day, I didn't have a robot. I had a cart full of sensors. Each new input brought more data, but not more clarity. Integration wasn't additive, it was destructive. The system didn't get smarter, it just got confused. This is what happens when you assume more sensors equates to better driving. That assumption ignores the hidden tax of complexity: calibration, cross-validation, maintenance, error reconciliation. It creates a design-by-committee machine where no one knows which input to trust and when. And that's not redundancy, that's fragility disguised as ambition. Tesla's decision to go camera only isn't about pinching pennies. It's about solving a harder, cleaner problem. Can we train a machine to drive using vision alone, the way humans do? And here's the obvious point. We already do this every day. Every trip you've ever taken in your car was powered by vision and vision alone. You don't have a LiDAR dome mounted on your head. You don't need radar to merge onto I-94. You've never once said, I can't pick up the kids until I rent an ultrasonic rangefinder. All you've got are your eyes and a brain that builds a model of the world from photons. Tesla is betting that we can recreate that, and if we can, why carry the weight of extra systems? Of course, LiDAR is a cool technology. It's accurate, slick, and undeniably useful in certain conditions. But useful doesn't mean necessary. Unless a sensor solves a problem that vision can't, without creating new liabilities in its wake, it doesn't belong in the system. That's not anti-technology, that's systems engineering 101. The real cost of LiDAR isn't the price tag of the unit itself. It's the organizational baggage, additional wiring, power, mounting, waterproofing, validation, regulations, and legal arguments over when the LiDAR should have kicked in, but it didn't. You're not just adding hardware, you're adding bureaucracy. And then we have the slippery slope of legal liability. Picture a courtroom someday where lawyers argue whether radar should have been prioritized over LiDAR during a 132.8-foot left turn scenario. Now you need to add departments just to manage edge cases like that, cases that have nothing to do with real-world safety and everything to do with sensor politics. Now, if we were designing a society of self-driving cars from scratch with smart roads, connected infrastructure, and coordinated networks, maybe radar and LiDAR would have a central role. But we are not. We are building vehicles that need to work today on every street in every country under every weather condition. Vision is the only input that satisfies that constraint, just as it does for human drivers. Still, that doesn't mean cameras are perfect. No sensor is. But when you commit to solving a problem with one well-understood, scalable input, you sharpen the engineering. You force clarity, and you leave the door open to future augmentation, but only if it's justified. Tesla's philosophy echoes the best of design thinking. The best part is no part. Don't optimize subsystems, optimize the whole. Don't pile on tools unless they make the system better, simpler, and safer, not just shinier. Is vision-only autonomy ready for prime time? That's a separate question. But is it crazy to pursue it? Not even close. It's arguably the only approach grounded in reality, biology, and deployability. The rest of the industry may be busy building camels. Tesla is trying to build the racehorse.